So, now that I've given a bit of a history lesson on Tor and some also very interesting things that can and have occurred on it, I'd like to tell you a little bit more about how Tor actually works and what happens to the data that's passed through the network. Typically, when you want to access something on the internet, you fire up your computer, pop open a browser, and type in the address you'd like to visit, or search for something with a search engine and then navigate to that address. In this situation, you are connecting from your home computer to your Internet Service Provider, or ISP, who then directs you to your destination. On Tor, however, things function a bit differently. For starters, as I mentioned before, you can't just use any old browser to access a darknet. Tor has its own, which is integrated with a special version of Firefox, as you can see here. While it is possible to configure your own access to the dark web, it is not recommended. The people at the Tor project work tirelessly to ensure the user experience on the Tor network is as safe and secure as possible. Utilizing the special Tor browser guarantees that you will have access to updates and patches specific to Tor at the moment they are available. In addition, the use of this browser in conjunction with Tails, a live operating system that you can boot from a USB or other external device, greatly increases security. Anyhow, once you've got your browser up and running, you can then connect to a Tor hidden service. But that isn't as clear-cut or direct as it is on the open web. Traffic travels from your computer through at least 3 nodes on the network chosen by your machine and finally to your destination. You can choose more than 3 if you're feeling paranoid. These nodes are hosted by volunteers all over the world, and your computer can connect to any of them. As you can see here, my computer has chosen 3 nodes located in the United States, the Russian Federation, and the United Kingdom. So we'll use those as our example. Because traffic can be sent from one side of the world to the other and back before reaching its destination, the dark web isn't exactly known for its speed. Therefore, users expecting the nearly immediate response they experience on their 100 Mbps connections at home may find themselves to be a bit disappointed. The 3 nodes or relays are known as your entry or guard node, your middle relay, and your exit node. I have 2 examples to show you to display exactly what happens to your data on the Tor network and why it's considered more anonymous than visible web communications. In my first example, you can see that the data essentially loses a layer of encryption as it travels from node to node, and at the exit node, as it travels to its destination, it is no longer encrypted. This key negotiation process utilizes a combination of public key encryption and what is known as the diffie-hellman key exchange protocol in order to carry out this action. In addition, due to the fact that nodes are hosted by volunteers on the Tor network, some checks and balances have been put into place in order to guarantee the integrity of the data as it's accepted by each node. Another way of looking at it is in this way. As I previously stated, your computer chooses 3 nodes on the network to pass your traffic to its destination. As this choice is made, your computer negotiates with these nodes 3 separate shared cryptographic keys in a particular way so that each node can only see that the traffic is meant for it and its source, but it does not know if you're the original sender of the data, nor can it see what's inside. Your payload and key are added to your data, and what comes out is known as a ciphertext. Once a layer of encryption is shed, or peeled off like the layer of an onion, so to speak, the node will then see the subsequent destination. And that's all the entry and middle relays can see. This key negotiation also prevents outsiders who do not know the key from deciphering what's been encrypted. To explain it further, your computer encrypts your data in this manner. The key you've negotiated with this exit node comes first. Your information and key go in, and out comes a ciphertext addressed to your destination. Encapsulating this is another layer formatted identically, but addressed to the middle relay. And finally, the last layer is once again formatted in the same way, with the rest of the encrypted data I've just mentioned inside of it, and addressed to your guard node. When your data arrives at the guard node, the node decrypts the first layer through the use of the negotiated key, to then find another layer inside addressed to your middle relay. It then sends the data to the middle relay, and the same thing occurs. The external layer is removed to find an address for the exit node, so it sends this traffic on its way. The exit node is responsible for shedding that last layer of encryption, and finally sending unprotected traffic to your destination. And from this stems the concept of malicious exit nodes. Traffic that travels through the Tor network remains encrypted until it leaves the exit node to travel to its final destination. Because of this, the user controlling the exit node is also in control of and can potentially view the traffic traveling from it. These anonymous nodes or relays can also be set up quickly and for very little cost. This means that a single person or organization could theoretically control numerous nodes throughout the network, and thus compare logging information to try and track down the sources of certain traffic. As I mentioned previously, you can choose more than 3 nodes in order to decrease the possibility that a single entity could possibly be managing each one. However, the likelihood of this happening in general is very slim. Much more detail on all of this to come in a future video. I'm very much looking forward to talking to you about this in more detail, but for now, if you've made it through all 3 of these videos, you're probably sick of listening to me talk. Before you go, I do have a very serious disclaimer for you, however. Do not go perusing around the dark web unless you know what you're doing. You could stumble across something far worse than what I've mentioned in this video and potentially end up in a lot of legal trouble because of it. Keep learning and developing your knowledge in this field before you decide to embark on a journey to the dark web. On a lighter note, it makes me so happy to teach about this and other technical topics. If you've enjoyed this or any of my other videos, please like, share, and subscribe, and have a great day!